Self-practice 4.8. Questions number 1. Triangle ABC has an angle of ABC equal to 60 degrees, AB equal to 3 such 3 cm, and BC equal to 4 such 3 cm. Determine the length of AC. So here I already prepared the diagram of the triangle ABC. It's going to look like this. So we have the angle at the B here, 60 degrees, and the length of BC is longer than the length of AB. Therefore, you're going to have a triangle look like this. Later on, when you learn the chapter solution of triangle, you can solve these questions directly using the cosine rule, as you have two sides, AB and BC given here, and one included angle using the cosine rule. But since let's say you haven't learned solution of triangle, so here we can split this triangle into two right angle triangles. So from the point A, I'm going to draw a straight line going down here, a perpendicular straight line towards the BC. And these points here, I'm going to label it as D. So here we already have two right angle triangle, the ABD, and another one is the ADC. So whenever you have the right angle triangle, you can always solve to find the length or the angle using the trigonometric ratio of sines, cosines, and tangents, or you can also use the Pythagoras theorem. Now, to find the length of AD, you can find the length of AD here. The angle that we have is a 60 degrees. So let us look at the triangle ABD. The AD is the opposite side of this 60 degree, and the BD is the adjacent side, and the AB will be the hypotenuse. Now, to find the length of AD, we're going to use the sine, as this is the opposite over the hypotenuse. So sine 60 degree equal to the opposite side. So I'm just going to label this using the AD over the hypotenuse, which is the 3 such 3. Therefore, AD is equal to sine 60 times 3 such 3. So sine 60 will give you the answer of such 3 over 2 multiply this 3 such 3. So solve this using a calculator, you'll find the answer is 9 over 2. Now, next, if you want to find the length of AC, we can solve the length of AC using the Pythagoras theorem if you know what is the length of the DC. So before we find the length of DC, let us find the length of BD. So still using the right angle triangle ABD, now we're going to use the cos. So cos 60 degree, which is equal to the adjacent sides over the hypotenuse. So the adjacent sides here will be the BD, and the hypotenuse 3 such 3. So BD is equal to the cos 60 degree times 3 such 3. The value of cos 60 is 1 over 2. So multiply this together, then you're going to get 3 such 3 over 2. That will be the length of the BD. Now we can find the length of DC. To find the length of DC, we're going to use the length of BC minus the length of BD. So BC is 4 such 3, whereas BD is the 3 such 3 over 2. So minus this one, and you're going to get the answer of 5 such 3 over 2. So as we know the length of AD and DC, so we're going to solve to find the length of AC using the Pythagoras theorem. So AC, which is the hypotenuse, so AC square will equal to AD square plus DC square. So the length of AD is 9 over 2. We're going to square it. And the length of DC is 5 such 3 over 2. Then we're going to square it. So here you're going to have 81 over 4 plus 75 over 4. Combine this together, then you're going to get 39. So this is the length for AC square. Therefore, AC is equal to the square root of 39 centimeter. Questions number 2. The diagram on the right shows a right angle triangle ABC. So A, determine the area of the triangle ABC. So we can find the area of the triangle ABC using the formula 1 over 2 times base times the height. So according to the diagram here, BC will be the base and AB will be the height. Therefore, the area will be 1 over 2 times 5 plus 2 such 2 and then multiply 5 minus 2 such 2. So here we're going to do the expansion for this part. Now this part is just like the expansions of A plus B multiplying the A minus B. Therefore, you're going to have A squared minus B squared. So in this case here, the A will be the number 5. So number 5, if you square it, then you're going to get 25. And then minus the B here is 2 such 2. So when you square it, it's going to be 4 times 2, which is equal to 8. Therefore, the area of the triangle ABC will be 17 over 2 centimeters squared. Now, for questions B, determine the length of AC. So according to the right angle triangle here, the AC is actually the hypotenuse. So using the Pythagoras theorem, AC squared is equal to AB squared plus the BC squared. So AB is 5 minus 2 such 2 squared plus the BC is 5 plus 2 such 2 squared. So here we're going to expand for both of these. So for the first one here, if you expand 5 squared, you're going to get 25. Then multiply these two. 5 times 2 such 2 is negative 10 such 2. Times 2 to it, then you're going to get negative 20 such 2. And the last one is expand this one. Negative 2 such 2. Then you're going to get a positive 4 times 2, which is equal to 8. So next, we're going to continue this part. This 5, square it, you're going to get 25. And then multiply these two together, you're going to get 10 such 2 times 2. Then you're going to get 20 such 2. Last one is going to be 2 such 2, square it, you're going to get 4 times 2, which is equal to 8 as well. Now from here, this negative 20 such 2 and this positive 20 such 2, we can cancel it, it will be eliminated. So just combine all the numbers together, then you're going to get the answer of 66. So this is the answer for AC squared. Therefore, the length of AC will be the square root of 66 centimeter. Questions number 3. Solve the equations 2 plus 3 such y equal to 6 such 3 plus 5. Write your answer in the form of A plus B such 3, where A and B are rational number. So solve the equations here is mean we want to find the value of y. And we want to return it in this form. So first, we're going to move this number 2 to the right hand side. Therefore, you're going to get 3 such y equal to 6 such 3. So this 5 will minus the 2. Therefore, you will get number 3. Next, I'm going to move this 3 to the other side. So it's going to be 6 such 3 plus 3 divided by 3. So 6 such 3 divided by 3, I'm going to have 2 such 3 plus 3 divided by 3 is equal to 1. So next, I'm going to move this square root to the other sides. Therefore, it's going to be the square of this. Alright, so this one is, you can do it just like the normal expansions. So if you do it slowly, so the first part here, you're going to have 2 times 2 is 4, and such 3 times such 3 is going to be 3, plus 2 such 3 plus 2 such 3 plus 1. So here 4 times 3 is 12, plus this one, you're going to have 13. And this is the similar sets, so we can plus them together. Therefore, you're going to have 4 such 3. So this will be the value of y. So it's already written in a plus b such 3 form. Questions number 4. Solve the following equations. So A, the square root of 2 minus 7x plus 2x equal to 0. So first, we're going to move this positive 2x to the right hand side. Therefore, you're going to have square root of 2 minus 7x equal to negative 2x. Next, I'm going to move this square root to the right hand side. Therefore, you're going to have bracket negative 2x squared. The negative 2x, when you square it, you're going to get 4x squared. So next, this is a quadratic equation. So I'm going to move this positive 2 and this negative 7s to the right hand side, so that I will keep the number 4 as the positive number. Therefore, you're going to get 4x squared plus 7x minus 2 equal to 0. So factorize this, then you're going to get 4x minus 1. The other bracket is x plus 2 equal to 0. Therefore, x is equal to 1 over 4, or the other one is x is equal to negative 2. So now, when x is equal to 1 over 4, when you substitute it back into the origin equations, the x, we're going to substitute it with 1 over 4. So the x here as well. Now here you're going to get square root of 1 over 4. And here you're going to get 1 over 2. So the square root of 1 over 4 is 1 over 2. So 1 over 2 plus 1 over 2 is equal to 1. So definitely this is not equal to 0. Therefore, the value of x equal to 1 over 4 is rejected in this case. So this will be not the value of x in these equations. And if you try with the x is equal to negative 2 and you substitute it back into the original equations here, so here you're going to have the square root of 16 minus 4. Square root of 16 is 4. So when 4 minus 4, definitely you get 0. So the value on the left hand side and the right hand side, they are equal. Therefore, x equal to negative 2 will be the value of x in this case. Questions 4b. So first, I'm going to move this positive square root 2x minus 1 to the right hand side. Therefore, you're going to get equal to 2 minus square root 2x minus 1. So next, I'm going to move this square root on the right hand side to the left hand side. Therefore, 2x plus 1 will equal to bracket 2 minus square root 2x minus 1 square. So on the right hand side, we need to expand this part. So we're going to have two brackets of the same terms. So you can do this slowly. 2 times 2 here will give you the answer of 4. Next, this number 2 we're going to multiply with the square root of 2x minus 1. So here we're going to have negative 2 times 2x minus 1 square root. And then the third one here will give you the same answers as well. And the last part here, negative will give you the answer of positive. So when the same square root multiply together, then you're just going to get the answer inside the square root, which is the 2x minus 1. So numbers with number 4 minus 1, here you got to get 3 plus the 2x. And for this part, you're going to get negative 4 square root 2x minus 1. So this is just like the like terms. So next, I'm going to move this negative 4 square root 2x minus 1 to the right hand side, and this 2x and plus 1 to the right hand side. Therefore, you're going to get 4 square root 2x minus 1 equal to 3 plus 2x minus 2x minus 1. So 3 minus 1, you're going to get 2, and these 2 will be eliminated. So next, I'm going to move this 4 to the other side. So it will be 2 divided by 4, which will give you the answer of 1 over 2. Next, move this square root to the right hand side. Then you're going to be bracket 1 over 2 square. So 1 over 2 square, you're going to get 1 over 4. Then I'm going to move this negative 1 to the right hand side. Then it's going to be plus 1. Therefore, 2x will equal to 5 over 4. Then move this 2 to the right hand side. It will be 5 over 4 divided by 2, which is the same as multiply it by 1 over 2. Therefore, x is equal to 5 over 8. Question 4c. So first, I'm going to move this minus square root 4x minus 1 to the right hand side. Therefore, you're going to get square root 4x plus 3 equal to 2 plus square root 4x minus 1. So next, I'm going to move these square roots to the right hand side, or you can square both sides, the same meaning. So here you're going to have bracket 2 plus square root 4x minus 1 square. Alright, so for the right hand side, we are going to expand it. So first, this number 2 with this number 2, we should give you the answer of 4. So the next one will be 2 times the square root of 4x minus 1, which is 2 square root 4x minus 1. Here will give you the same answer as well. And the last one here, we get a positive. So when the same square root multiply together, we're just going to get 4x minus 1. So next, we're going to solve for the first one is the number 4 minus 1 here. We're going to get 3 plus the 4x, which is alone there. And these two, sum it up together, then you're going to get 4 square root 4x minus 1. So this is equal to the 4x plus 3. So next, I'm going to move this 3 and this 4x to the right hand side. Therefore, you're going to get 4x plus 3 minus 3 minus 4x. So here 4x minus 4x will be eliminated and 3 minus 3 will be eliminated. Therefore, on your left hand side, it will be equal to 0. Alright, So next, move this 4 to the other side. It will be 0 divided by 4, which is still equal to 0. So now I'm going to write this square root 4x minus 1 on the left hand side. So here is equal to 0. So next, move this square root to the other side. So 0 square is still going to be 0. So 4x minus 1 now equal to 0. So move this 1. So 4x is equal to 1. Therefore, x is equal to 1 over 4.